Okay, good morning, everyone. Okay, so I just did this calculation for the Games Fair. I just wanted to kind of help you with the report now. So after you've got this ready to run, and so say this is going to be our table of values here, and I'll just use this one for the sake of uh, argument. We could use the other one too if you prefer that. When you actually run your game, so you play the game, so I want you to run to at least 100 trials. And so you can play it a lot of different ways. You can play it online just with random.org. You can actually run the game, shuffle. You can get a friend to play it, however you want to do it. When you actually simulate your game, instead of having the probabilities calculated, what you're going to do is you're going to have the total number that you have. So instead of having maybe this column where you've got P of X, you're going to keep a tally of every time you get 0, 1, 2, 5, 12, and 102. And so find out how many times that happened. So say out of 100 trials, this happens 20 times out of 100. And say this one happens 40 times. I'm just going to use nice numbers. So our probabilities now become experimental probabilities. And so we'll say this one happens 30 times out of 100. We'll say this one happens, so what's that, 70, 90. We'll say this one happens 7 times out of 100. So equals 7 divided by 100. Say this one happens 2 times out of 100. And this only happens once out of 100. Then you've got all your trials, and you got your probability here. And again, you still have XP of X. And so the average that actually happened was based on this outcome, because the $102 did come up and it's not supposed to. You actually paid out 61 cents per trial. If that doesn't come up at all, which makes sense, like equals 0 out of 100 or just 0, and this guy maybe came up 8 times, then your experimental probability would be a lot closer to your theoretical. So in the Games Fair, what you're going to have to compare is these two numbers here, why they're a little bit different. So in the report, but I also want you guys to compare charts, and so I'll show you how to set up the chart. And so if you highlight this, because you maybe want the title and then all the dollar values, and you just hit Insert Chart, it'll give you a recommendation for a type of chart that you want. You don't want a circle graph. We want actually a bar graph. You just want to click off a couple things. So you want to use row 1 as headers. You're going to use column B as labels. We're going to aggregate column B so that so it doesn't show up 102 farther than 12. And that's going to be your chart that you're going to compare. And so we'll click Insert there. And so we've got one chart for our theoretical probability, and then we do the same thing. We just hit Insert Chart. And again, we go to chart types. We just make sure that we got column G as labels. If we hit aggregate, then it won't have that big gap between to 100. So aggregate, and then it's got all the outcomes here, and these are the actual probabilities that happened. And so you've got a history or a bar graph there to compare. And so that way you can clearly see the difference here versus here. It's generally the same shape. I just set the trials just quickly there, but these numbers you're actually going to pull out when you actually play the game. And so this is going to be the focus of your report, is comparing these two graphs. Notice that the scales are different. But comparing the two graphs and comparing the two expected values, so the minus 0.4 to the minus 0.36. And this is where you focus on law of large numbers and that kind of thing.